Hello everyone, and welcome to this presentation on a fascinating problem in complex analysis. Today we are going to compare two seemingly similar expressions, I to the I and minus I to the minus I. At first glance, you may think these are equals, but as we will discover, the answer is more nuanced than it appears. We'll explore complex exponentiation, multi-value function, and beautiful in the cases of complex numbers. Let's to solve it. We have two complex expressions, I to the I on the left and the I to the minus I to the minus I on the right. The question is, are they equal? If so, what is their value? If not, why not? This is a classic problem in complex analysis that beautifully illustrates the multi-value nature of complex exponentiation. Let's to solve that step by step. How to compare Z to the W. For complex numbers Z of W, in the complex numbers Z to the W equals to E to the W ln Z, where ln Z equal to ln of absolute value of Z plus I multiply argument of Z plus 2 pi k, and k is integer. The key points are the complex logarithm. Logarithm is multi-valued. Each choice of k gives a different branch. The principal value uses k equals to 0. The answer depends on which branch we choose. Let's go to computing I to the r. Step 1. Find ln r. The logarithm of I equal the absolute value of I equal to 1. So ln of absolute value of I equals to 0. Argument of I equals 2 pi over 2 plus 2 pi k. K is integer number. So ln I equal to I multiply pi over 2 plus 2 pi k. So I to the I equal to e to the I multiply ln I equal to e I multiply I multiply pi over 2 plus 2 pi k equals to e to the minus pi over 2 plus 2 pi k. The principal value for k equals to 0. We have I to the I equals to d to the minus pi over 2 approximate equals to 0.20788. And then we are going to compute minus I to the minus I. The second step is find ln minus I. The absolute value of minus I equals to 1. Then ln of absolute value of minus I equal to 0. So argument of minus I equals to minus pi over 2 plus 2 pi k. K also is integer numbers. Ln minus I equals to I multiply minus pi over 2 plus 2 pi k. So minus I to the minus I equals to e to the minus I ln multiply ln of minus I equal to e to the minus I multiply minus pi over 2 plus 2 pi k equals to e to the minus I to multiply minus pi over 2 plus 2 pi k equal to e to the minus pi over 2 plus 2 pi k. The principal value for k equal to 0, minus I to the minus I equal to e to the minus pi over 2 approximately equal to 0.20788. So the principal value of I to the I equal to e to the minus pi over 2. And principal value of minus I to the minus I also equal to e to the minus pi over 2. So we can conclude I to the I equal to minus I to the minus I equal to e to the minus pi over 2 approximately equals to 0.20788. That equal in the principal value. This is equal only for the principal values. So we have comparison on multi-valued. What about all branch? On possible value of I to the I to the I equals to e to the minus pi over 2 plus 2 pi k equal to e to the minus pi over 2 multiply e to the minus 2 pi k. K is integer numbers. All possible value of minus I to the minus I to the minus I equals to e to the minus pi over 2 plus 2 pi k equals to e to the minus pi over 2 multiply e to the 2 pi k. So the key observation for I to the I equals to e to the minus pi over 2 multiply e to the minus 2 pi k. And so the value for minus I to the minus I equals to e to the minus pi over 2 multiply e to the minus 2 pi k. We can see the difference only related to the sign of e to the 2 pi k in the last term of expressions. There are different sets. We can see they are different in the last terms. Here we have the comparison table. Expression, the R value at the principal value of expressions of I to the I and minus I to the minus I. For the I to the I, the R value equals to e to the minus pi over 2 multiply e to the minus 2 pi k. And principal value is e to the minus pi over 2 approximately equals to 0.20788. And for minus I to the minus I, our value equals to e to the minus pi over 2 multiply e to pi k, e to the 2 pi k. And principal value for the minus I to the minus I equals to e to the minus pi over 2 approximately equal to 0.20788. Final conclusion is the principal value, they are equal. But for our branch, they have different sets. The answer depends on the branch. So they are equal, it depends. For the principal value, they are equal, but for other branch, other set, they are not equal. Here also, we can see the visualization of I to the I and minus I to the minus I on the unit system. We can see the what have the magnitude of 1, but different arguments. For the I to the I, the argument is pi over 2, but for minus I to the minus I, the argument is minus pi over 2. Also, we get the visualization of the value. For k equal to 0, I to the I and minus I to the minus I both have the same value, e to the minus pi over 2, approximately equal to 0.20788. So they have overlap at the principal value. But for k equals to 1, we can see they are different, I to the I. We can see the left side, and for the k minus 1, minus I to the minus I, we can see although it has overlap with the I to the I. Here we can but say on this for k equals to 1, the I to the I and minus I to the minus I have different value. But for k I to the I for k equals to 1 and minus I to the minus I for k equals to minus 1 are same value, because the difference related was related to the minus sign. So sets differ but overlap at the principal value. it we can see the two insights. We learned that the complex exponentiation, computing of I to the I and computing of the minus I to the minus I, and comparison in the principal values and all of that, we can see that they are equal in the principal values, but have differences for other branches. The summary of the lesson is I to the I versus minus I to the minus I. Their principal value is the same, are the same. E to the minus pi over 2 approximate equal to 0.20788. But our branch there are different sets of values. And final answer, they are equaling principal value but not at multi-value sets. Thanks for watching. See you in next video.